There we go. Now it's recording. Okay, and let me share the screen. Share screen, yes. Right here. Okay, so basically what we're doing today is we're going to figure out how to do everything that is being asked to do in this particular test question, which was released in 2010. So that's what I want to do. So let's first start with figuring things out in terms of the components that they want you to know here. So let's start here with, and I'll pick a serious color here. So the first thing is a distance. Distance. Do you guys intuitively understand distance of something? How far something is away from you? Okay, so let's begin. So let's say something here is at 0 and something else here is at 5. How far away are they from each other? 5. How do you figure that one out? Can you tell me the math you did? 5 minus 0. How about that one? Subtract. Does that make sense? All right, let's change the numbers a bit. I don't know. Let's go ahead and do 1 and 5. How far away is 5 from 1? And how would we do that? Yeah. Okay, so we can subtract to figure out distances. Agreed? No problem there? Now, okay, so he's having issues. Okay, so now, let's say you have this one here at 10 and this one here at 7. Can you figure out this distance? It's 3. Okay, I mean, it doesn't matter if the line is this way or this way, right? Horizontal or vertical. You just subtract and you get the distance, right? It's like, you just count. Basically, it's not even counting. It's less than counting. It's subtracting, all right? But where it becomes tricky is when it looks something like this. Now, obviously, if you knew where this was and this was, like let's say I wrote this 2, 3, and you know it's a coordinate, right? Like the first one's the X, the second one's the Y, right? And this one, say this one was 5 and the other one was 7, right? And so it's a slanted line in a two-dimensional, obviously a coordinate plane. We call it a coordinate plane, Cartesian plane, right? And I asked you to find a distance here. Like, yo, I need that distance. Now, can you do it? Well, you should be able to do it. So what we do is we split it in 2 parts. We split it into the vertical component and the horizontal component like this. Do that. And guess what that forms? It's called a right triangle. And right triangles, like, what's the thing that you remember from right triangles? It starts with a P. Pythagorean theorem. Remember that? It's a squared plus b squared equals to c squared. So now let's do this. Can you figure out the distance from here to here? What will you do? The horizontal distance, how would you figure it out? From here to here. Anybody? Anyone? Yes.
You can subtract the 5 by 2.
Yeah, 5 minus 2. 5 minus 2. Do you see why? Because this here and the X is 2. See, remember, this is an X and this is a Y. So this is also an X and this is a Y. So the distance from here to here is just going to be 3. How about here? How will we figure that distance out? Yeah, it's 4. It's 7 minus 3, which is 4. Good. So basically what we have here is a 3, 4 on those legs. You see that? That's what we have. Could you now find this guy here? See? In other words, a squared plus b squared equals to c squared, right? Let's go this up. Agreed? Now, if that's true, then we have 3 squared plus 4 squared equals c squared. What's 3 squared? What's 4 squared? So that's 25 equals c squared. So c equals the square root of 25. I shouldn't have to explain this here because, right? So what's the length for this side? So this is 5, right? It's a 3, 4, 5 triangle. I picked those nice numbers because, does that make sense? Okay. So let me go ahead and copy this for a second. Copy. I'll paste it down here. So I pasted that down here. Now, instead of writing a 2 here, I'm going to change this 2 to x of 1. So I'll just write here instead x of 1. And this guy here is now y of 1. And then this guy over here, x of 2. And this guy over here is y of 2. So now this here, which was 3 before, is just take x of 2 and subtract x of 1. See that? And this here is y of 2 minus y of 1. And if this is a right triangle, then if I square this plus square this and square root that, I get that. In other words, d squared equals x of 2 minus x of 1 squared, whatever you get there, plus y of 2 minus y of 1 squared. And then d must therefore equal the square root of x of 2 minus x of 1 squared, plus y of 2 minus y of 1 squared. And you're done. That is your distance formula. That's how you get your distance formula. Make sense? That's it. That's all it is. And unfortunately, we have to stop there for now because we're going to go to lunch. But I'm not going to mess this one up. I'm going to go ahead and I'm going to pause the recording and hopefully not lose it so I can continue it when we come back. And that would be something that's good. So let me go ahead and just pause the recording, Zoom recording. So here we are. All right. So any questions on the distance formula? How was your lunch, by the way? It is hot. I walked 2 miles. Did I tell you that? Yeah, I did. I walked 2 miles. So I'm sweaty. All this is sweaty back here. But what was for lunch for you guys? You're not sure what it was? Was it human grub? What was it? Really? Something with cheese. But did it taste good at least? I'm sorry to hear this. All right, guys. Any questions on distance formula? I think most of you are pretty solid with this. Okay, so the next thing is let's talk about, and let me go ahead and get a ruler. Let me close my door for safety concerns, right? All right, guys, doors closed. So have you guys done midpoint before? Do you remember the formula for midpoint? Yes, no, maybe? Okay, something like that, right? Okay, okay. So let's talk about midpoint. Let's say this is 0 and this is 10. What's the middle between those two? 5. Is everybody in agreement there? Is there somebody here like, bro, that's wrong? Why is it 5? Why is the midpoint 5? It's half of 10, right? But like, what if I did this? The midpoint between 7 and 10. Would it be half of 10? No. So what would be the midpoint? Well, like 10 minus 7 is 3. 3 divided by 2 is 1.5. 1.5 plus 7 is 8.5. Right? So agree that that's how you do it? Now, what I want you to realize is this. This is what I want you to realize. That the distance between here and here is 5. And the distance from here to here is also 5. That's how we know it's the midpoint. Each part here is the same size. Agreed? Now, when we do it here, we said it was 8.5. If I take 8.5 and subtract 7, that's 1.5. I take 10 and subtract 8.5, that's 1.5. Agreed? All right, good. So now let's see if we can do it with letters. Are we gonna try to do it with letters? So here's what I'm gonna do. Whatever number you can pick, here's the first number. Whatever number you pick, here's the second number. Okay. I want to figure out this guy here in the middle such that these two pieces are the same. So that when I take x of 2, and let's call this m here, and I subtract m, right? When I take x of 2, and I subtract m, and then when I take m and subtract x of 1, they both equal each other. Would that be fair? That's what I want. For instance, here, over here, you see this part? Nobody had a problem with me saying 10 minus 5 is 5, and 5 minus 0 is 5. Agreed? Isn't that the same thing I'm doing there, but with letters? Okay, but the great thing about letters is, which is the unknown letter there? M. So let me go ahead and rewrite it here, but in like a different color, like purple. So m minus x of 1 equals x of 2 minus m. I'm going to solve for m. What's the first step I should do there to solve for m? What should I first do? Well, I just add m to both sides, shouldn't I? And then I'm going to end up with 2m here. This guy's gone, right? I still need to solve for m, right? So I'm going to add x of 1 to the other side. So 2m equals x of 2 plus x of 1. Agreed? And now I'm going to divide by 2. Both sides by 2. And so my midpoint says take both numbers, add them, and divide by 2. Look at that. What's 10 plus 0? Divided by 2? Great. What's 10 plus 7? Divided by 2, you'll see it's 8.5. So the way you find a midpoint is you add the numbers up and divide by 2. That's all you do. And guess what? Guess what? If you had a line that was inclined like this, and it was composed of x1, y's of 1, and this one x of 2, y's of 2, the midpoint for this would be x of 1 plus x of 2 divided by 2, comma, y's of 1 plus y's of 2 divided by 2. That's what it would be. Have you seen this before? Yes, you have. When I was in school, well, I remember being so worried about not memorizing anything. Like in kindergarten, I had trouble with colors. That was a difficult test. Now you take it for granted, right? Well, same thing with these things. As you start, same thing, timetables, as you go further and further and further. But this is just something you learn. The best way to learn it is to really understand what's happening. And you'll always remember it. Or, hey, guess what? Practice. The way to get good at anything is practice. Period. But the thing is, can you get home after spending 4 periods of the day here? Tackle your homework, right? Do everything you need to do. Eat, maybe have some entertainment, work out, because you got to work out, right? Everyone here has to work out, right? And do your hobby. Do you have enough time? No, you don't. You don't. So you have to be really good. Have to be really good. But this is interesting. If you develop the skills, you're gonna be able to get some decent majors, and you're develop your thinking skills. You'd be surprised. All right. Any question or concern on midpoints? How to do it? Question or concern? You've done this before. Don't worry, because there'll be more examples. All right, so I'll make a line here. All right. So there we go. So now, the next thing we're going to do is called slope. Do you guys remember your slope? Yes. What's your slope? Correct. They love saying the word gradient. We usually use the word gradient in construction. The grade, the gradient. So it is y to 2 minus y of 1 over x of 2 minus x of 1. This is rise over run. Basically, that's what it is. Rise over run. So we got to remember that in order to get your slope, you can do it a few ways. You can look at a picture and count the rise over run. I can give you 2 coordinates and you get the numbers and do it, right? Do I have to show you how to do slope, or anybody here wants to me go over how to do the slope? No, you're good? Are you sure? I don't mind. I'm gonna pretend you're that person that needs to see an example right now in my head. Oh, yes. So here's an example. Here we have 2 points. I'm I need a slope, bro. So you're gonna be okay, x of 1, y of 1, x of 2, y of 2. Slope is gonna be y of 2 minus y of 1 over x of 2 minus x of 1. And as you're doing this, you're talking to yourself like I'm doing it. And guess what? It's gonna stay there forever. You'll get Alzheimer, but you won't forget this. 5 over 2. Look at that. Because you repeat it over and over again. Now, what's interesting to talk about here is if I gave you a graph like so, and this is a coordinate plane, a Cartesian plane. Here's the horizontal, here is the vertical. And I gave you something that looked like this. And it's kind of awful what I've done there because you can't really see it, but I'll zoom in here and I'll also zoom in here. Okay, like so. And I'm I hope I did it right, but I went over 1. So here's my run. My run is 1. And then I go 1, 2, 3, 4. And my rise is 4. So my slope is rise over run. So my slope here should be 4 over 1. Do we agree? So we can also do it from inspection on the graph. We can do it by using the formula, right? Now, what's interesting here is that you got to remember that what the point of this slope stuff is to be able to do lines, all right? And that's where we're aiming. Let me go ahead and make sure I'm not skipping anything because that would be sad. Yes. Only if you're careful. All right, so so that's what the book does. It just basically just says, here's a slope, and it gives some examples of it. Okay. Now, what's interesting is in that formula right there, in that slope formula, if I were, and let me go ahead and pick another color, I don't know, like blue. So let's say I wrote the formula out for slope, but instead of calling the first one y is of 2, I just wrote y because I don't know it. And I write y is of 1 equals x minus x of 1. I could do that. I can write my slope formula like that. But the great thing is I can rearrange this. And I can write the following. M times x minus x of 1 equals y minus y's of 1. And we don't really like writing it this way. We write it this way. We go y minus y's of 1 equals m times x minus x of 1. And we call this point slope form of a line. That's point slope form of a line. Why? It's giving us two pieces of information. It's giving us the slope, and it's giving us a point. So if I write the following, y minus 2 equals 2/3 times x minus 5, I may ask you, hey, what's the slope? And you will say, the slope is 2/3. And I go, yo, what's the point? And you would say, 5,2. We always do the opposite. Now, if you inspect it, you'll see why it has to be the opposite, and you'll see it in your homework. So if I were to graph this quickly, I have all the essential information I need to make a graph. To make a line graph, I need either 2 points or I need a slope and a point. In this case, I have a slope and a point. So here we go. Let me make it prettier. I can do a better job, can't I? You know why? Because I have a ruler. None of your teachers are using a Microsoft Surface? Tell them they should. Really, tell them that. Don't say such things. They're creatures just like you and me. All right, so 5, 2. Here we go. We graphed it. And look at this. 1, 2, 3. 1, 2. So I go 1, 2, 3. I wouldn't do that on my paper. I'm just doing it because I'm pretending to be a teacher. Okay, and I go up. 1, 2. Yay! I have just sketched this guy. Is that hard? No, it's a game we play. Do you remember this? Okay. Now, guess what? And I know it's a lot, but it's not that much. Well, yeah, you know what? It is quite a bit. Especially on the first day after you return from a slow summer, right? How many of you played video games the whole summer? Just that's it. What were the rest of you guys doing? This work? I'm sorry. Oh, vacation. I hate you. All right. All right. So let me ask you guys a question. Do you guys remember, like, what do you call where we cross the axis? Like if we cross the x-axis, what do we call that? Yes, we have something called the x-intercept. And if we cross the y-axis, what do we call it? And could you tell me when we cross the x-axis, what value is y? Yes, y equals 0. And in the case of a y-intercept, what's the value of x? 0. And this is true. This is true. So if that's true, then let's go ahead and talk about it. right? If I have an x-intercept, can you tell me like what you want to call this? I don't know. Let's do the y-intercept one. Let's say we have x is 0, y will be b. Okay. Let's say I give you a slope. Here's the slope, m. So let's do this. Y, well, let me label stuff for you guys. I'm gonna label it in red. Let's call this x1, y1. We have y minus y's of 1 equals m times x minus x of 1. Y minus b equals m times x minus 0. You saw that? Y minus b equals mx plus 0, basically, or minus 0, however you want to say it. So y equals mx plus b. Have you ever seen that before? What is this called? Slope intercept form, because it gives you two pieces of information. It gives you your slope and specifically your y intercept. Yes. Now you can similarly do that for the other one, but we don't have a formula for that. This, you could just leave it as is. Just remember, for an x-intercept, y equals 0. Now, if I give you a formula, an equation, y equals 3x minus 2, could you tell me when it's written in that form, what is my slope? And what is my y-intercept? So the coordinate would be 0, negative 2. Do you have enough information to make a sketch? Yes, you do. You simply, and I know it's going fast, but it shouldn't feel too bad. Right? If I do a quick sketch of this, 0, negative 2, then the slope is 3 over 1, which is 1 over 3 up. 1 over 3 up. And this is a quick sketch of y equals 3x minus 2. That's what it is. What do you think? Bad or good? Good, bad? You understand? Whatever. I know it's a lot. It's not that much, honestly. So that's called your slope intercept form. Now there's one more form to go over, and it's called standard form. Standard form. Excuse me. So this form looks like this. Where A, B, and C are integers. And A is positive. Very important to remember. A is positive. You guys are so quiet. What's wrong? This is the first day and you're just quiet. Is anybody sad? All right, what is this form good for? Honestly, I don't find this form very productive, but they're gonna want you to do it sometimes. This form, like maybe to find your intercepts, it's you just set x to 0 and find y, or y to 0 and find x. We'll do it sometime, but you know, whatever. It's not an enormous deal. Yeah. There's plenty of practice putting these things together. I'm not interested in that today. There'll be plenty of times where I'll give you homework. Yes. Slide it up. Yeah. If you see that, I forget to slide it up. Don't be shy coming up here. I don't have corona. I don't think so. Is that even still a thing? Yes. Only if you care. So The next thing I want to talk about is I want to talk about, and I'll zoom out. I guess I can make like another little line here. Wow, really a lot of notes today. Quite a bit, don't you think? Let's see if I can get this to go the other way. No, of course not, because that would be awesome. Give me a second. There we go. Go over here. All right. So now we're going to start talking about a few other things, and then I'll try to get into a set of problems. All you got to do to get good at these things is just do the homework and try to do it right. That's it. And then once you know how to do the simple things, then maybe you can do a complex question. It's not complex. It's like putting a puzzle together, but you need to understand the things and you need to imagine in your mind. And it just takes time. It takes time. That's all. You gotta put in the work. Put in the work. Can't overemphasize that. All right, so now we're gonna talk about the concept of parallel lines. Do you know what parallel means? That they will never do what? They will never touch. They will never cross. So two lines that are parallel, guess what happens when two lines are parallel? What do they have in common? They have the same slope. Very important. So when they're parallel, they have the same slope. When they're perpendicular, they do this. They form a right angle. We would say that they're normal to each other. They're normal to each other. And what's interesting is that if you take the slope of this line, let's call it M1, and you got the slope of this line, M2, and you multiplied it together, you take M1 times M2, guess what number you get? You get -1. So what essentially that means is if this were like 1/3, then what number would I multiply 1/3 to equal to -1? Well, x must equal to -3. Right? I would have to multiply both sides by the reciprocal. Right? So this guy would have to be, yes, sir. Huh?
The gradebook manager.
You know, I wish I knew, man.
Got a
Rodriguez, his last name?
It's a woman, right?
Yes,
Rodriguez, you think?
I think so, man.
Oh, thanks.
Sorry. I don't pay attention enough. Yes. Oh, sorry. So this is 1/3, and this has to be 3, -3. Well, what's -3? Isn't it -3/1? Let me make that nice 3. That's like a horrible 3. Right? What if, and this is perpendicular, of course. What if my slope M was 2/3? What would be, and I'll use this perpendicular to it, like I'll do that. What would that be? -3/2. We say it's the negative reciprocal. Do you remember that? Negative reciprocal. Okay. So far, so good. So let's take a look at a problem together. Like a test for these questions. I know this is probably going overboard. It's okay. I'm gonna give you homework so you build up to hopefully being able to do a problem like this. But again, you have to practice. There's no way around it. If like, no matter how much you pay attention in this class, unless you already know stuff. Now, if you know stuff, you know stuff. If you don't go home and practice and you come back and talk to me about it, what you didn't understand, if I give you homework and you go home and you try to do it, you can get some of it done, but you couldn't do this question. And you honestly, you couldn't almost, like you had dreams about it, you know? and you come here to class and you ask me and you're actually interested, you're probably going to eventually know how to do that problem, right? You worked, you put me to work, made me earn my money, and you learned something. And you do this over and over and over again for 90 classes. If you put in 100 hours of work in this class, real work, you will pass the exam. But if you don't, if you only put a total of 10 hours of work all year, don't expect to pass the exam. It's that simple. It really is. I really want you to understand that. I say this every year, by the way. Okay? It doesn't matter. I'm just, prove me wrong. I don't want to be negative, but I just want to be real. Okay, so here we go. Let's take a look at this question together. You haven't seen it because I haven't shown it to you, but there it is. And let me zoom in a little bit more. And hopefully I have enough space to start talking about it. So you get a question like this. Obviously, we're not there yet. This is unfair what I'm doing, but it's the first day of school, So it says that the diagram shows a triangle ABC. There it's labeled, in which A is 3, -2, B is 15, 22. The gradients of AB and BC are, and look at what they do, right? So for AB, the gradient for AB is 2m. The gradient for AB is -2m, like that. And for BC, it's m. And it says m is positive. Okay, that's what they do. Can you imagine that? They don't even give you numbers, bro. So I'll just go ahead. When I see this, if I'm doing this question right now, I'm writing on the side, I'm going, the slope of AB equals 2m. The slope of AC is -2m. And the slope of BC is m, where m is a positive constant. Okay, so if m is positive, it means that the slope of AB is also positive, but the slope of AC is negative, because a positive times a negative is going to come out negative, which makes sense from the picture. If I look at AC, it's going downward, right? So that's a downward slope. But when I look at AB, it's upward, and BC, it's upward. So I know it's a positive slope. Now it says, I find the gradients of AB and deduce the value. Now they did give us some numbers. They said A is 3, -2, and B is 15, 22. And they want me to deduce the value of M. Can you do that? Okay, so let's do AB. Do we have numbers that we can use to get AB? Yes. So the slope of AB is what? Okay, so all right. So here I'm gonna go. I'm gonna start labeling stuff. Let me pick a color here. Let's go with purple. Which one? Which color do you want? Okay, okay. All right, well, let's go over it. So here's what I would do first. I'll go x of 1, y's of 1. X of 2, y's of 2, right? And then we say, okay, so I'll start working, since I don't have enough space, I here. We have y's of 2 minus y's of 1 equals x of 2 minus x of 1. This must equal the slope of what? AB, right? All right, what's y's of 2? 22. 22 minus -2, right? Over 15 minus 3 must equal what? Does it equal slope of AB, or does it equal 2m? It equals 2m. What does m a to b equal to? 2m. So go ahead and do it. 2m. So 22 minus -2 really is 22 plus 2. Because when you subtract a negative, it becomes a, so that's 24. And 15 minus 3 is 12. So 2m equals to what? 2. So 2m equals to 2, but m equals to what? Guys, let me pause this. My wife is calling me. All right. So I found the value of m. M is what? 1. Guess what? Now you know slope. This is 1. This is this is 2. This is -2, and this is 1. Now you know slope of everything. Be careful. Does that make sense? Is that super duper hard? No, you could do this, but you know, now it says, yo, find the coordinates of C. You don't have the coordinates of C. You need to find the coordinates of C. Now, just because I'm going to go ahead and fill this out over here. And again, this is not the way I would fill out on a test. Obviously, I don't have the space, but this part 2 is challenging. So we got, sorry, because 2 times 1, -2 times 1, and 1. So now you know the slopes of each of these, right? You know the slopes of everything. So it says find the coordinates of C. So you need to find now this guy here. All right. Now, the way you would find this is you would have to find the intersection of these two lines. So let me go ahead and show you. If you had the equation of this line, and you had the equation of this line, and you were able to simultaneously solve them, you would find that point, wouldn't you? Okay, so since nobody responded, let me make it clear. I'm gonna leave it like that. I'll give myself some space. I'll write 2 right here. Okay, look at this guy here. So we're looking at this guy. Can you tell me the point associated with that line? So we're talking about line AC. So line AC, can you tell me the point it has? 3, -2, right? What else do we need to form an equation of a line? A slope. What is the slope of AC? -2. So the slope of AC is -2, right? So do we have a formula we just talked about called point slope form? Yes, we did. And can we put it in point slope form to get an equation? Yes, we can. So let's do that first. Y minus -2 must equal -2 times x minus 3. So that's y plus 2 equals -2x plus 6. And so it's y equals -2x plus 4. Check to make sure I didn't make any mistakes in my arithmetic. This is the equation to AC. And guess what I got to do now? I got to figure out the equation to AB. Don't I? Because I want to figure out where they cross. So I'm going to line, the next line is AB. No, sorry, AC. And I ask myself, hey, what is the point for, no, that's a B up there. This is line BC. What is the point that I have for BC? Huh? 15, 22. And what's my slope of BC? 1. So y minus 22 equals 1 times x minus 15. Right? What am I using here? I'm using point slope. Do you want me to remind you here? Watch, I'm gonna remind you. I'm going to remember we're using y. I should really Let me make it a little bit prettier, guys. I'll put it out here. Remember, point slope. Y minus y of 1 equals m times x minus x of 1. Okay, so good. We have that. Let's just finish up, make it look prettier. The way we make it look prettier is by rewriting it in slope intercept. See, that's what I've done. Y minus 22 equals x minus 15. And then when you add the 22 over, what's 22 minus 15? So you have two equations. You got negative 2x plus 4 and x plus 7. Agreed? Now, just quickly, before I continue, what time does this class end? What time? Oh, yeah, like now? Oh my gosh, no, I'm gonna run out of time. So let me hurry up. So I gotta put la pilas. Okay, so and now I'll just finish the next class, whatever, life continues. All right, so here we go to well, you know what? I can do it. No, yeah, I can, yeah. Desmos. So Desmos graphing calculator. You can log on here and do it quickly, but I'll do it also. So I'm gonna go ahead and put here in the graphing calculator, negative 2. Come on. Negative 2x. What? Why? Oh, I see why. I know what's happening. Because numlock is not on. Negative 2x plus 4 is that line. And then you have the next line, which is x plus 7. So here's the intersection. What is the intersection? That guy, right? See it? It's right there. Like this. This will do it for you. Right? Negative 1, 6. Now, when we go to our thingy here, we're going to solve it too. We're going to get that same thing. Now, what do you know? When they cross, what do they have in common? The same intersection. It has the same x and y. Agreed? Now, do they have the same y when they cross? Yes. So let me just set them equal to each other. Just set them equal to each other. Negative 2x plus 4 equals to x plus 7. You can explicitly do that. And then you just go ahead and solve that. 3x plus 7 equals to 4. Right? Subtract the 7, right? That's going to be negative 3 equals 3x. Divide by 3, divide by 3. X equals to negative 1. We just found the negative 1. And now all you do now is you take this and substitute it into any one of those, right? You could do that. And if that's the case, you have, I'll just go ahead and pick the first one. So if you go ahead and go y equals negative 1, I'll go ahead and write it out. So let's say I picked, come on, computer, erase. If it's x plus 7 and I substitute in there, y equals negative 1 plus 7, and guess what you get? 6. If you do to the other one, y equals negative 2x plus 4, and you write y equals negative 2 times negative 1 plus 4, you get 2 plus 4, which equals to 6. So what is your intersection point? Negative 1, 6. So your intersection would be negative 1, 6. But of course, the problem is not done. We're only halfway through it. And apparently, you know, class is almost over. But I'll leave it at that. I think that's quite a bit. There's no homework for today. But again, if you do the homework, you should be able. Oh no, don't create a break room. You should be able to do this.